Hey guys, welcome to Safi Mixed. In this video, I will let you know how to make simulations like these two figures in Mathematica. So let us begin by understanding the procedure for simulating the first figure. This, in fact, is a 3D plot of a two-argument sinusoidal function that I am writing over here, where I plot it under the function or command plot 3D, and I vary the values of x from 0 to pi and the values of y from 0 to 0.85 times pi. I put the command viewpoint with arguments 1, 1, 1 so that I watch the figure in a right plane. Then I add the command mesh with none, means I ask Mathematica to show no mesh over the figure, and I apply the color function who, and I set boxed false and x is false. So the Mathematica will not show me the box of the figure and similarly will not show the x's. If I run this command, I get this figure. So now I want to rotate this figure. So now I want to rotate this 3D figure by using three other functions of Mathematica, and they are respectively given by rotate, graphics 3D, and manipulate. So this single line command would do the job what you saw previously as figure 1. What I do here, I add to the argument of rotate three different options. The first one, this is an unknown variable that I add at this position, and I ask Mathematica to rotate the figure at position this one, which is plot that I saved previously in this line, by a degree A whose values I vary from 0 to 360 degree, and then I ask Mathematica to plot range all along z-axis, and again I ask Mathematica not to show the axis, and then I add again the plot at sequence number 2 into the argument of graphics 3D, and then finally I ask Mathematica to rotate what has given to the arguments of graphs 3D and rotate function by an angle from 0 to 35 degree. If I run this line, I get this figure. You see here a simulation argument which is denoted by A, and it is exactly this parameter. If I add the simulations at this position and I play the values, you will see the simulation would begin. So it is rotating. I can reduce the speed by pressing this button. If I press it twice, the speed will further be reduced, and if I press it thrice, it will get very slower. I can change the rotation, the direction of rotation from anti-clockwise to clockwise by pressing this arrow. Now you see the figure is rotating clockwise. And I can put this in automatically by reversing the direction by pressing this arrow once more. Now you see both. Now you see once the figure will rotate clockwise, and in the other it would start the other way around and would begin to rotate anti-clockwise. So I'm done with this one, and now let us move to the simulation of second figure that I showed you in the beginning of this video. And for that figure, I first define a function which is given by x raised to the power 5 minus x raised to the power 4. I read this to Mathematica and then I plot this function through the command revolution plot 3D. This is a kind of 3D plot that gives values along the two axes and show the 3D geometry of this single direction or one parameter function. Then I asked Mathematica to plot this function under this revolution plot 3D command for values x0 to 1, and again I use the other function box false, axis false, mesh none, color function, function xyz who along z axis, and I read both of these lines to Mathematica. And finally, I again use the same three function, rotate, graphics 3D, manipulation, and the same parameter A, which will rotate the figure through, this time from 0 to 2 times 360 degrees. And if I run this part, I get this figure. And if I simulate the values of A, I see it is now rotating, but this is rotating very fast, so I want to reduce the speed a little. More. And similarly, I can change the direction of rotation by pressing this button. Now it is rotating anti-clockwise. And if I press the arrowhead once more, it will start rotating back and forth, that is anti-clockwise and clockwise. So this way you can simulate a 3D figure to rotate either clockwise or anti-clockwise smoothly with an angle of your choice. For example, in the previous case, I took the angle to varies from 0 to 360 degrees, and in this case I'm taking it from 0 to 2 times 360 degrees.